Alrighty, let's take a look. We gotta do some Taylor and Maclaurin polynomials. So, and series. Find the fourth Taylor polynomial, P4, for sine 3x centered at pi over 6. Whew, that's a lot. So I've got sine 3x. Since I'm doing some polynomial stuff, let's go ahead and take derivatives. The first derivative is 3 cosine 3x. The second derivative is negative 9 sine 3x. The next derivative is negative 27 cosine 3x. So that's the first, second, third derivative. I want the fourth degree. So that means I need the fourth derivative. So that's going to be 81 sine 3x. Now when I plug in pi over 6, 3 times pi over 6 is pi over 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. Sine of pi over 2 is negative 9. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So that means I'm going to take the initial value to that. I need to multiply by x minus pi over 6 because of my center. And then minus the 9, x minus pi over 6. So that's the first derivative, second derivative, over 2 factorial. And then 81, x minus pi over 6, I almost wrote 4, to the fourth over 4 factorial. So that would be my fourth degree Taylor polynomial. So then we want the general Taylor series to look like. So it would just kind of continue that pattern. So let's see if we can look at that pattern. Analyze this pattern piece by piece. We've got 1, we've got 9, which I can write as 3 squared, and then 81, which I can rewrite as 3. So this is 3 to the 0. So the general term is going to be 3 to the, I'm pausing, 2n. So I make sure it's even, and that's going to be n is 0. And I'm realizing, goofball, this is not the derivative, that's just the first piece. So I just write that number. That'll fix everything. So 3 to the 2n, and then if I had an x minus pi over 6, I could write it here. X minus pi over 6, that'd be to the 0. So it's going to be x minus pi over 6 to the 0, sorry, to the, not 0, because that was 0, to the 2n. And then over 2n factorial, because it's going to go 0, 2, 4, 6, etc. Don't confuse the fact that we skipped some pieces over here because the odd ones went away. Because the odd derivatives went away. Once we have our series, we ignore all the 0 stuff, and then we can rewrite what our general term might look like. Then we want to talk about under what conditions would this series converge. So there's a lot going on. Let's go ahead and try so the divergence test won't get us anywhere. So let's go ahead and try the ratio test. So the limit as n goes to infinity, absolute value. So that's the an term. So the an plus 1 term, be careful, be very careful, be very, very careful here. That's going to be n plus 1. And then x minus pi over 6 to the 2n plus 1. Notice that I'm replacing the n with n plus 1 over 2n plus 1 factorial over 3 to the 2n, x minus pi over 6 to the 2n, and then over 2n factorial, so flippy floppy, 2n factorial. Now let's consider this. So that gives us the limit as n goes to infinity. That's going to be 2n plus 2 minus 2n is 3 squared. And then x minus pi over 6 squared over, so that's 2n factorial, 2n times 2n minus 1, etc. It's like 2n minus 2 and so on to 2 and 1. And then we've got 2n plus 2. So 2n plus 2, 2n plus 1. Okay, here we go. This is where we see it. And then 2 and 1. So all of this stuff cancels out. So we'll wind up with 2n plus 2, 2n plus 1. We could still have absolute value here. As n goes to infinity, that's going to be 0, which is less than 1. So that converges for all x in the reals. X in the reals. There we go. Whew, a lot going on there. 6. For the following Taylor functions, find the Taylor series centered at C with a general term and interval of convergence. All right, I'm not going to do them all. I'm going to show you what I would do. So, on a previous video, I think, or in class, we should have shown e to the x. So all the derivatives e to the x are e to the x. When I plug in 0, I get 1. So it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. So then e to the negative 3x. Oh, they want the general term. So this would be x to the n over n factorial. So e to the negative 3x is 1 plus negative 3x plus negative 3x squared plus negative 3x cubed, and then negative 3x to the n over n factorial. So it's a kind of a substitution problem. That's all it is. If we want x e to the negative x, so do this part first. E to the negative x, ignore that, e to the negative x is just going to be 1 minus x plus x squared minus x cubed. You should be able to figure out why it's like this. And then the general term is, I'll break it into pieces, negative 1 to the n, x to the n over n factorial. You could just do negative x to the n, that'd be fine. And then if I want the x version of that, so x e to the negative x is x minus x squared plus x cubed. Nope. There we go. Minus x to the 4th plus negative 1 to the n, x to the, okay, so it's x to the n times x, which is x to the n times x to the 1, and therefore I add the exponents, and then we keep going. So try to do that. Try to write out what the sign is, and then plug in. Try to write out what it is for the natural log. If you haven't done the natural log, build the natural log of x, and see if you can plug in. Let's write a few more centered at 0. Okay, so some more to play with. And we already did this one. We basically did that one. It's very similar to what we already did. If I can do this one, then I can do this one. So let me do those ones. So let's start with 5. So we got the sign of x cubed. Well, the sign of x, the sign is odd, so that's going to be 1 x minus x cubed over 3 factorial, x to the 5th over 5 factorial, x to the, so it's odd, so 2n plus 1 over 2n plus 1 factorial. If you don't believe me, start taking derivatives. Notice that all the even pieces go away. And then I want x cubed. So the sign of x cubed is going to be x cubed cubed, x cubed to the 5th. So that's 15. X cubed, I'm going to write it right here just to show you what's going on. 2n plus 1, so multiply. So that's 6n plus 3 over 2n plus 1 factorial plus. So we did that one. And then for the cosine, cosine is an even function. So cosine, so that's going to be 1 minus x squared over 2 plus x to the 4th over 4 minus and so on. So that's going to be x to the 2n over 2n factorial. And I just realized I forgot something. Negative 1 to the n. And I forgot something in the sign. There should be a negative 1 to the n. That didn't change. Sorry about that. Realized I dropped that. Now let's go to cosine of x to the 3/2. So that's going to be 1 minus 2 times 3/2 is 3. 4 times 3/2 is 2 times 3, which is 6. I guess that should be minus, I don't care. And then negative 1 to the n. X to the 3/2, so 2n times 3/2, those cancel, so 3n. X to the 3n over 2n factorial. Now we just need to put an x on. So let's go ahead and do that. Shrink-a-dink. And so x cosine, x to the 3/2 is going to be x minus, so x cubed times x is x to the 4th. X times x to the 6th is x to the 7th. And then we'll have negative 1 to the n, that doesn't change. 2n factorial doesn't change. And then we'll have x to the, so that's x to the 3n times x to the 1, so x to the 3n plus 1. If you're confused by this part, think linear functions. You're going, whoa, what happened there? You're going 1, 4, 7. So it's like a line that starts at 1 and has a slope of 3. So hence the 3n plus 1.